All right, so in section 3.4, we are talking about matrix multiplication. And before we actually get into how to multiply matrices, let's talk about just regular matrix operations, and then we'll move into multiplication. So we're starting with matrix operations. All right, and so let's look at a couple examples that we'll use. All right, so let's look at a matrix A, and down the columns we got -5, 1, 0, and then 2, -3, 4. And then let's look at another matrix, call it B. Down the columns we got 1, 0, -2, and then 2, 1, 3. All right, and let's actually keep track of the dimensions of these matrices because dimensions are very important when it comes to matrix multiplication. So the first one is a 3 by 2 matrix, and so is the second one. All right, first let's talk about multiplying a scalar times a matrix. So let's look at 5 times our matrix A. How does that work? Well, we got the number 5 times this matrix. Okay, so multiplying a scalar by a matrix means that we need to multiply every single component by that number. So in the first position, 5 times -5 is -25. Then over here we got 10, 5, -15, 0, 20. All right, so this is 5 times the matrix A. All right, now let's talk about addition of matrices. So let's look at A plus B. In order to add two matrices, they have to have the exact same dimensions because the result will have the exact same dimensions. All right, so we got A plus B, so we're going to take our matrix A, add to the matrix B, okay. All right, and then the way that we add these together is component-wise. So the resulting matrix will have the same dimensions, and in the first position, we're going to add these two together. We got our -4 here. We need to add these two, +4, and we'll continue adding component-wise here. All right, so this is how we add our matrices. And then, of course, we can combine this. We can scalar multiply and add and subtract all at the same time. So let's say we want to find 2 times matrix A minus B. All right, so that's 2 times A minus B. All right, so order of operations will still apply here. We need to do the multiplication first. So we're going to scalar multiply first. Okay. All right, and then we're going to subtract component-wise. So -10 minus 1 is going to be a -11, and so on. All right, so these this is how you do matrix operations. So scalar multiplication, addition, and subtraction. All right, it's a little more tricky when you're multiplying a matrix by another matrix, so let's go over what's happening when we do that. All right, let me just scoot all this up. Okay, so matrix multiplication. All right, so let's consider a matrix. So let's consider m by n matrix A and n by r matrix B. So like I mentioned, dimensions are very important when it comes to matrix multiplication. All right. So what I want to look at first is B. So the matrix B, which is an n by r matrix, so it has n rows, r columns. Okay. Remember, we can always write a matrix as columns side by side. So that's what I'm going to do. I'm going to write it as B1, B2, all the way to BR, since I know we're going to have R columns. All right, and the length of each one of these column vectors is going to be n, the number of rows. So each one of these are n by 1 in dimension. Okay, so think about what that means in your mind. So we can write every matrix in this way as columns side by side. So if we're going to write B this way, that means we can define A times B as the matrix A times all of these vectors, right? So we can write it like this. AB1, so that's a 1 here. Let me see if I can make that look better. AB1, AB2, I'm messing up here. Let me rewrite this. All right, so we're going to define A times B as A times B1, A times B2, on down to A times BR. And remember, when we multiply a matrix times a vector, so this matrix is n by n, and the vector is n by 1, the result is going to be another vector. So each one of these are actually vectors, n by 1 vectors. And so if this matrix A times B is composed of a bunch of m by 1 matrices, and there are r of them, that means the resulting product, A times B, has dimensions m by r. All right, so take some time to let that sink in, and then I'll start a new video for the next section.